Chapter 13 General Rules of Probability. 13.1 Combining Events. First, let me review the necessary notations. The union. What is the union of two events? Suppose there are two events A and B. The union of A and B is the set of outcomes that belong either to A, to B, or both. We use this notation to show the union, A union B, or we can call A or B. Then the intersection. What is the intersection of A and B? The intersection of A and B is the set of outcomes that belong both to A and to B. We use this notation for the intersection A intersection B, or we can call A and B. What is the complement of an event A? Complement of event A is the set of outcomes that do not belong to A. We use this notation for the A complement and this, and also you can use this notation. Example number 1. Here we have the sample space S and two events A and B. First one, asking A intersection B. What is the A intersection B? We can write A and B. That is the both elements of A and B. That means common elements. What are the common elements of A and B? We see 3, A is common. So we write 3. Then 6 is common. Therefore 6. This is the A and B. Then let me go to the part B, asking A union B. Or we can say A or B. What is the union? Union is the whole set of outcomes that belong either to A, to B, or both. Right, you see here we have 0 in A, therefore 0 here. Then 1 is in B, 1. Then 2 is in A, 2. Now next 3. 3 is in both A and B. But we write only one time here 3 because no repeated element. Similarly, you can write 5, 6, 7, 8, 9. All elements of A and B or both. That is the A union B. Now, how do we write the complement? A complement. So that means all elements not in A. Right. Let me consider A and S. We need to compare A with the sample space. A 0, here 0 here, and 2, 3, 2, 3, 6, 8, 6, 8. Now, what are the rest of the elements in S? Elements are 1, 4, 5, 7, 9. That is the complement of A. Now let me explain complement of B. First consider the element of B. Elements are 1, 3, 5, 6, 5, 6, 7, 9, 7, 9. Now we can write the complement. What is the B complement? B complement is all the elements not in B. Then we see 0 is not in B and 2 is not in B, 4, 8. These are the elements that is not in B but in S. So that is the B complement then. Now go to the D. Complement of A intersection B. Or you can write this one A and B complement. So how do we find the A intersection B complement? First, let me find the elements A and B. Yes, we already know it. A and B is 3, 6. Now compare A and B with S. We have 3 here and 6 here. So then we can write the rest of the element. What are the elements? 0, 1, 2, 4, 5, 7, 8, 9. That is the complement of A and B or A intersection B. The last A union B complement. How do we find this? You can write this A or B complement. Then first understand the elements in A or B. This is the A or B. So these are the elements. Also we call sample points. Elements of B is here. So then consider with S. So 0 is there and 1, 2, 3, 5, 6, 7, 8, 9. We have only just one element left, right? Therefore, A or B complement is 4. Now let me explain how to represent this event using Venn diagrams. What is the Venn diagrams? Venn diagrams represent the sample space and events. Suppose there are two events. We use this rectangle to represent the S. S is the sample space. Here and here also the sample space. Then how many events we consider for this? Only two events. So I call A and B. So I use the circles to represent these two events. We normally use circles. What is here A intersection B? A intersection B is the common area or common element of A and B. Now how do we identify this region? Let me explain this way. So first we have A. So I color this A event. This is the event A. Then we have B. So event B is this. I use the yellow color. Then go to the notation. What is the notation? And notation. If you see and notation, then we consider the area with both colors. We use here two colors, therefore we consider the area with both colors. So which area that has both yellow and green? You see this middle area, this one. So that is the intersection. So you see here this Venn diagram represent the A intersection B. Then go to the A union B. Let me show you how to do this one. Again we have S, the sample space, and A and B, those are the events. Then first let me color this A using yellow color. So that is the event A. Then go to the event B. It is blue color. This is event B. Now check the notation. What is the notation we have here? Union. Okay, if you have union notation, then we use all shaded region. It doesn't matter one color or both colors. So we use shaded region. So that is the A union B. Now let me explain example 2. Provide a graphical representation of the following events. As I mentioned before, the rectangle represents the sample space S. Okay, first one is A complement. How do we show a complement using this Venn diagram? First, let me identify the A. A is the circle, this circle, that is A. But we don't need A, we need a complement. What is the A complement? A complement is the every element but not in A. That means out of the circle A, like this. That is the A complement. This is the A complement. Now go to the next one, A union B complement. Okay, first let me show you A union B. You already know that region, that area. So this is the A union B. But we need complement. Complement is the out of now these two circles or out of these shaded areas, that should be this. So that is the A union B complement, only green color. That is the A union B complement. Next, only A. What is the only A? Let me explain this. This whole circle, this circle, what is this? This represents A, right? This represents A. But you see here in the middle area represent both events A and B. Therefore, what is the only A? Only A is this part. The circle in the circle A, but not the area with B, right? Not common region. That is the only A. Then you understand how to show only B. This is the part, the area that represent only B. Now let me explain example number 3. Here we have the sample space, the same example we discussed before, and A and B two events. List the elements of the sets corresponding to the following events. Here let me explain this using a Venn diagram. So first we need to identify how many events we have here. There are two events. What are those? A and B. So I use rectangle for the S and this circle for the event A. This one is event for event B. First of all, we need to identify the elements in the common region here. What is that common region? That common region is A intersection B. We know already. Now identify the elements of A intersection B. So what are the elements of A intersection B? We know we can say here A 3 and 6. 3 and 6 are the elements of A intersection B. Therefore, first we fill this region with 3 and 6. Now consider this A. You see in the A, we have two elements already. They are 6, 3. And also in event B, there are two elements already, 6 and 3. Now let's go to fill the area only A. How do we fill the area only A? Consider the rest of the elements of A. So we see here 6 and 3, they are already in A. The rest of them are 0, 2, 8. Now you see we have all elements in A. Similarly, go to the B. We see 6 and 3, they are in B already. The rest of the elements are 1, 5, 7, 9. We need to consider now the sample space. Now check both circles. We have 0 and 2 and 1, 5, then 9, 7, 8, 6, 3. We have all elements already in S because within two circles, but 4. Therefore, 4 is not in A or not in B. Therefore, 4 should be outside of the circles here. So, this is the complete Venn diagram for this problem. Then you can write the elements. Ask in A intersection B, you know the area A intersection B. So that is this middle area, this part, that is 6, 3. So 3, 6. Then B, so let me write it down. A union B, what are the elements then? You see 0, 1, 2, 3, 5, 6, 7, 8, 9. Then C, A intersection B complement. Yes, what is the A intersection B? Let me write down this first. A intersection B complement. Let me show you A intersection B. A intersection B is this. That is the A intersection B. Then we need the complement. Complement is the all elements out of that region. So you see then 0, 1, 2, 4, 5, 7, 5, 7, 8, 9. Those are the elements of A intersection B complement. The next one, the last one, D, A union B complement. What are the elements of A union B complement? First, we need to identify the region of A union B. Now I use this. This is the A union B. That means the area with both circles, right? Either A, B, or both. What are the rest of the elements? We have only 4. Now you can go with the 3 events. So then how do we draw Venn diagram? For the 3 events, you see here there are 3 circles, A, B, C. Then this represent, first one, this represent A intersection B intersection C. What is the A intersection B intersection C? Or the common area for all of them. So you see this is the common area for all of them. How do we identify this? Let me show you how to do it. This is A, this is B, and C, the sample space, S. So A, B, C. We need A, so I color this A, whole area of A. Then we need B. Let me color this B using green color. The last one is C. Okay, so C is this. As I mentioned before, now go with the notation. A intersection, B intersection. So we have intersection. If we use intersection, if we have intersection, then we consider the area with each colors. Then how many colors we use here? 3 colors. So what is the area with 3 colors? You see here only one area, here and here the same. But the middle part here, this one, it is only 2 colors, right? And here 2 colors, 2 colors. The only region that with 3 colors is this. This is the region A intersection B intersection C. Similarly, you can try this one A union B union C. So how do we identify this? Again, we need S, the sample space. There are 3 circles, 1, 2, 3, A, B, C. Right. Now we have A. There are actually three sets, but we can make it to first one A union B. But you know already A union B, you know how to find it. So I will color using the yellow. This is the A union B. Then we have event C. So this is the event C. That is the event C. Then what is the notation in the middle? That is the intersection. Again, if we consider intersection and then we consider the area with both colors here. We use only two colors here, right? Then you see this area has both green and yellow, and this area the same, and this one. So that is the way we identify the area according to the notation, the same one. Now let me explain the here this one. Okay, S. Here also you should know we need S for each. Okay, so here there are three events. So 1, 2, 3 events, A, B, C. So what is the first one? Okay, here we see A first. Okay, so I use A first. A is this. Then I go with B intersection C. Is this one? You see that is the B. Then C is this one, right? So intersection is this. B and C intersection is this. Okay. So yeah. Then what is the middle one? Middle one is union. If you see union, then you know the area is the all shaded region, right? All shaded region. Yes, you see this is the area, then the same is here. Now let me explain how to draw a Venn diagram for the disjoint events. In chapter 12, I explained disjoint or mutually exclusive. What is the meaning of disjoint or mutually exclusive? If there are no common elements, then they are mutually exclusive or disjoint. If so, how do we use Venn diagram to show it? You know this is S. Mutually exclusive mean again no common element, then we don't need that part. Two circles separated like this because no common elements. That is the Venn diagram for the two mutually exclusive events.